All right, let's go over the answers to the examples from the notes from last time on the Pythagorean theorem converse. So just a reminder of what this converse tells us. So if you have a triangle, the side lengths can tell you whether it's right, obtuse, or acute. So if this is true, this is the Pythagorean theorem, a squared plus b squared equals c squared. If that's true, then the triangle is a right triangle. If c squared is greater than a squared plus b squared, then the triangle has to be obtuse, meaning it has one obtuse angle. And if c squared is less than a squared plus b squared, then the triangle is acute, meaning it has 3 acute angles. So we like to keep c squared on the left side like this, just to avoid confusion. Yeah, just because if c squared is on the other side, then you would have to flip the inequality around, and that might get confusing. So if you leave it on the left, then you know greater than means obtuse, and less than means acute. All right, so first things first, we need to check that this is actually a triangle. So the way we do that is we have to check that 18 plus 24 is greater than 30. So we have to see if that's true. So 18 plus 24 is 42. So 42 is greater than 30. So that's all set. So it's definitely a triangle. So now we need to check if it's acute, right, or obtuse. So we can cross that one out because we know that's not true. So C is always going to be the largest side. So that means 30 is C. And let's just say 18 is A and 24 is B. So 30 squared, we want to know if that's greater than, less than, or equal to 18 squared plus 24 squared. So what's 30 squared? Well, that's 900. 18 squared is 324, and 24 squared is 576. So this is still 900, and this happens to also be 900. So those are equal to each other, which means that it's a right triangle. Okay, next one. So again, we need to check if this is a triangle. So we need to see if 8 plus 15 is greater than 23. So again, just making sure we're on the same page here. You need to check that the two smaller sides are greater than the largest side. So A plus B has to be greater than C for it to be a triangle. So that's why in the last one we checked 30. This time we're going to check 23 here because it's the largest side. So 8 plus 15 is not larger than 30 because that's 23. Oh, I'm sorry. We're not talking about 30 anymore, 23. But it's still not larger than 23. That's not true. They're the same, and that's not okay. Because if you were to draw a triangle with these, it would actually look like a line, so it's not a triangle. So this is actually not a triangle. So we're done. And we move on to the next one. So for this, we want to check that 31 plus 35 is greater than 39 because, again, 39 is the largest side, so that's our C. So 31 plus 35 is 66. That's definitely bigger than 39, so we know it's a triangle. So now we just need to check the Pythagorean converse. So 39 squared, we want to know if that's equal to 31 squared plus 35 squared. So 39 squared, check that on my calculator, that's 1,521. 31 squared plus 35 squared. I'm going to do that in my calculator all at once. That's 2,186. So our C squared is smaller than A squared plus B squared, which means that we have an acute triangle. All right, last one. So we need to check that 11 squared, or sorry, just 11 plus 19 is larger than 28. Because 28 is the biggest side that they give us here. So 11 plus 19 is 30, which is bigger than 28. So that means it is a triangle, so we can get rid of that. So now we just need to figure out what kind of triangle it is. So we want to know if c squared, so 28 squared, we want to know if that's equal to, smaller than, or greater than a squared plus b squared. So 28 squared, checking that on my calculator, that's 784. And then 11 squared plus 19 squared is 482. So c squared is larger than a squared plus b squared, which means it's an obtuse triangle. So that's it for the Pythagorean theorem converse. It's just saying that if you have a triangle, you can figure out what kind of triangle it is just by the side length.